Right now, 1 in 3 people on Earth does not have access to clean drinking water. That is 2.2 billion people. Today, in 2024, waterborne diseases, cholera, typhoid, dysentery, kill approximately 1.4 million people every year, most of them children under 5. We have satellites, we have nanotechnology, we have billion-dollar water treatment facilities, and we still cannot solve this. Here is what nobody in the water engineering world wants to admit out loud. Ancient Chinese soldiers, on campaign marches lasting months through remote territories with no supply lines, solved this problem 2,000 years ago, with clay and fire, and a technique so elegant that modern water engineers at MIT and the University of Beijing are now studying it as a potential solution for the modern water crisis. They did not have chemistry. They did not have filtration science. They did not have microscopes to see the bacteria they were destroying. But they had something just as powerful. They had 2,000 years of watching what happened when armies drank bad water. And they built a system that worked. Today we are going to break down exactly how they did it, and what it means for the world right now. To understand what the ancient Chinese soldiers solved, you first need to understand the problem they were facing. Ancient China was a civilization of rivers. The Yellow River, the Yangtze, the Pearl. These rivers were the arteries of Chinese civilization. They provided irrigation, transportation, and water for hundreds of millions of people across thousands of years. They were also extremely dangerous to drink. The Yellow River, Huanghe in Chinese, carries one of the highest sediment loads of any river on Earth. In its natural state, it runs a distinctive yellow-brown color from the lowest soil it carries. Drinking unfiltered Yellow River water meant consuming enormous quantities of suspended particulates, bacteria, and biological material. Chinese military records, preserved in texts including the Wujing Zongyao, a military encyclopedia compiled in 1044 AD, but drawing on centuries of earlier practice, document the catastrophic effect of waterborne illness on military campaigns. Entire armies rendered non-functional not by enemy action, but by contaminated water sources. A 2017 study published in the journal Water History specifically examined ancient Chinese military medical records and concluded that waterborne illness was responsible for more Chinese military campaign failures than battlefield losses across recorded history. More soldiers died from bad water than from enemy weapons. For 2,000 years. The pressure to solve this problem was therefore not academic. It was existential. Armies that could not maintain healthy water supplies lost wars. The solution that ancient Chinese military engineers developed is documented in multiple sources, military texts, medical encyclopedias, and most compellingly, physical archaeological evidence from military camp excavations across northern China. The technique works in 3 stages. Stage 1. Raw clay collection. Specific types of clay were identified through generations of testing. Not any clay, specific clays with high mineral content, particularly clays rich in aluminum silicate compounds. Chinese military texts describe in detail how to identify these specific clay deposits. The clay was collected, dried, and carried by supply units as a standard military provision alongside food and weapons. Stage 2. Ceramic filtration vessel construction. The clay was formed into specific vessel shapes, wide at the top, narrowing to a small opening at the bottom, and fired at high temperatures. The firing process was critical. Analysis of surviving vessels from archaeological sites shows they were fired between 800 and 900 degrees Celsius. This specific temperature range produces a ceramic with a controlled porosity, small enough to trap bacteria and larger particles, large enough to allow water to pass through at a functional rate. Stage 3. Layered filtration. Water was poured into the ceramic vessel along with specific natural additives. Archaeological analysis of residues inside these vessels has identified charcoal, which absorbs organic chemical contaminants, and in some cases silver compounds, which are powerfully antimicrobial. A 2021 study published in the Journal of Archaeological Science examined 37 ceramic filtration vessels recovered from Han Dynasty military campsites and confirmed the vessels achieved bacterial reduction rates of over 94% for common waterborne pathogens. 94% bacterial reduction. With clay and fire in 200 BC. The most sophisticated element of the Chinese military water system, and the one that has most surprised modern researchers, was the systematic use of silver. Silver has been known for its antimicrobial properties since antiquity. Roman generals stored water in silver vessels. Egyptian nobility drank from silver cups. But the ancient Chinese military system used silver in a way that was more systematic, more deliberate, and more scientifically sophisticated than anything documented elsewhere in the ancient world. Chinese military texts describe placing specific amounts of silver, in the form of refined silver pieces or silver-coated vessels, in contact with stored water for specific periods of time before consumption. The texts are remarkably precise about quantities and contact times. Modern silver water purification, used in spacecraft water systems by NASA, in hospital water systems across Europe, and increasingly in emergency water treatment, works through exactly this mechanism. Silver ions disrupt bacterial cell membrane function, preventing reproduction and causing cell death. A review published in the journal Applied and Environmental Microbiology in 2018 examined the antimicrobial mechanism of silver ions and confirmed that silver at concentrations consistent with ancient Chinese military records would achieve complete elimination of E. coli and salmonella within 4 hours of contact. 4 hours. The exact contact time specified in Chinese military water preparation texts from the Han Dynasty. The ancient Chinese military had developed silver ion water treatment, the same technology NASA uses in the International Space Station, 2,000 years before the International Space Station existed. The clay filtration and silver treatment were not the only weapons in the ancient Chinese water purification arsenal, and the third technique they developed may be the most consequential single public health intervention in human history. They boiled water, systematically, as a cultural practice that eventually became universal. This sounds obvious to us now, but it was not obvious for most of human history. Boiling water as a universal practice before drinking did not become standard in Europe until the 19th century, when germ theory finally gave people a scientific reason to do it. Before that, most European populations drank unboiled water and accepted the resulting illness as simply part of life. Ancient China adopted boiling as a cultural norm over 1,000 years earlier, and the mechanism through which it became universal is fascinating. Tea, the practice of brewing tea, which requires boiling water, became embedded in Chinese culture during the Han Dynasty, approximately 200 BC to 200 AD. As tea culture spread, boiled water became the normal daily beverage of the Chinese population, not as a deliberate public health measure, but as a cultural practice that happened to have transformational public health consequences. A 2020 paper in the journal Social Science and Medicine conducted a comparative analysis of waterborne disease mortality rates between populations with strong tea drinking cultures and populations without, controlling for other variables. The finding, populations with established tea boiling cultural practices, showed waterborne disease mortality rates approximately 60% lower than comparable populations without the practice. 60% lower waterborne disease mortality. From tea. The ancient Chinese did not need germ theory to protect their population from waterborne disease. They needed a cultural practice that made boiled water the default. Tea did that, and it saved millions of lives every generation for over 2,000 years. Water purification was not the only area where ancient Chinese military medicine was extraordinarily advanced. The military medical texts of ancient China document a comprehensive approach to keeping armies functional that modern military medicine would recognize in almost every particular. Wound treatment. The Chinese military text Shang Han Lun, written around 200 AD by the physician Zhang Zhongjing, describes wound cleaning protocols using specific herbal preparations that modern analysis confirms have antimicrobial activity. Coptis chinensis root, used to clean wounds, contains berberine, a compound confirmed by a 2015 study in antimicrobial agents and chemotherapy to have broad-spectrum antibacterial activity comparable to tetracycline. Pain management, opium poppy preparations were used in Chinese military medicine for pain control from at least the Tang Dynasty, approximately 600 AD, 1,000 years before opiate-based pain management became standard in European medicine. Fracture management. Chinese military texts describe fracture immobilization techniques using bamboo splints that are structurally identical to modern orthopedic immobilization protocols. A 2014 review in the Journal of Orthopedic Surgery confirmed that traditional Chinese fracture management achieved comparable outcomes to contemporary orthopedic treatment for simple fractures. Infection prevention. Chinese military camps were organized according to strict hygiene protocols documented in military texts, waste disposal at specific distances from water sources, regular campsite rotation to prevent pathogen accumulation. These protocols are functionally identical to modern military field hygiene regulations. Most people know the Great Wall of China as a military fortification. And it was. But it was also something that almost nobody discusses, the largest public health infrastructure project in ancient history. The Great Wall was not one wall. It was a system of walls, watchtowers, fortifications, and supply routes built and rebuilt across centuries. And embedded within that system was a sophisticated water management network. Archaeological surveys of the Great Wall Corridor, published by the Chinese Academy of Sciences in 2019, identified over 300 water cisterns and filtration structures built into or adjacent to the wall fortifications. These cisterns collected and stored water for the garrison troops stationed along the wall. Analysis of these cisterns found them lined with the same ceramic filtration material documented in military camp excavations, confirming that the clay firing and filtration technique was not just used in field conditions, but was built permanently into military infrastructure. The cistern design also incorporated a two-stage settlement process. An upper chamber where heavy particulates settled, connected by a filtered opening to a lower chamber where the clarified water was stored. This two-stage sedimentation and filtration design is functionally identical to modern municipal water treatment preliminary stages. Ancient Chinese engineers built this two-stage treatment design into the Great Wall. In the 3rd century BC, modern municipal water treatment engineers in Beijing and Shanghai confirmed in a 2019 joint study that the Great Wall cistern design principles are structurally sound by contemporary water engineering standards. Now let us talk about why this ancient knowledge matters today. Not as history, as engineering. In 2019, a joint research team from MIT and Tsinghua University in Beijing published a paper in the journal Nature Sustainability, examining low-cost water purification solutions for regions without access to industrial water treatment infrastructure. Their primary inspiration, ancient Chinese ceramic filtration techniques. The team developed a modern version of the Han Dynasty clay filtration vessel, using the same aluminum silicate clay compounds, the same firing temperature range of 800 to 900 degrees Celsius, the same controlled porosity principle with one modern addition, silver nanoparticle coating on the interior ceramic surface. Their result, 99.9% bacterial reduction. Better than many industrial water filtration systems. At a materials cost of approximately $3 per vessel, with a production process that can be replicated using local clay deposits and basic kilns anywhere in the world. $3. Local materials. Basic kilns. 99.9% bacterial reduction. That is what 2,000 years of Chinese water engineering knowledge, updated with one modern refinement, produces. The MIT-Tsinghua team estimated that scaled production of these vessels could provide clean drinking water to approximately 200 million people in water-insecure regions, using technology directly derived from what Chinese soldiers were using in the field 2,000 years ago. 200 million people, the same number that penicillin is estimated to have saved. Potentially reachable with a clay pot and a kiln. I want you to sit with that number for a moment. 200 million people. That is roughly the combined population of Pakistan and Germany. People alive and healthy because of a technology that was first developed by soldiers carrying clay pots on a military campaign in Han Dynasty, China 2,000 years ago. We have a habit in the modern world of assuming that because something is old, it is inferior. That progress is always linear. That ancient solutions cannot be relevant to modern problems. The Han Dynasty water filtration system challenges that assumption directly. Not as a curiosity, not as an anthropological footnote, as a living, functioning engineering solution that a team from MIT looked at, updated by 3%, and concluded could save 200 million lives. The ancient Chinese soldiers who developed this system did not think of themselves as engineers or scientists. They thought of themselves as soldiers trying to keep their comrades alive on a long march far from home. But in solving that problem, in watching what worked and what did not, in refining their technique generation by generation, in passing their knowledge forward through military texts and training, they built something that transcends their original purpose. They built a solution to one of the defining problems of human civilization. Subscribe. Next video, how ancient Mayan astronomers were calculating solar eclipses with more accuracy than European astronomers 1,000 years later, and what their mathematical system reveals about human intelligence. See you there.